Alright, now we are going to prove this equation over here. That's the velocity of the orbit. As you see, depends on the universal gravitational constant, the mass of the Earth, and the distance from the satellite to the center of the Earth. Not the surface of the Earth, but the center of the Earth. This equation is very important. We are going to use it in another problem later on. Okay, this is the equation that we want to show. As I said, your book prefers to be using 1/2 as exponent, but remember that can be written as this as well. Okay, remember that square root is exponent 1/2. Alright, how to prove this equation? First, we have the Earth over here and the satellite over here. I always draw the satellites like this because these are solar panels. So this is the distance, r, not to the surface of the planet, but to the center of the planet. So this has mass m, and this has m sub e is going to be the mass of the Earth. So we have the gravitational pull between the Earth and the satellite. This is universal law of gravitation. In the other exercise in this series, we know that the centripetal force, we got mass times centripetal acceleration, and when this object is orbiting, is executing a circular path, then for this case the acceleration is toward the center. So you have the acceleration is always center looking, and that's what centripetal is. And this is another way, you know, that this is changing velocity over time, but because the magnitude of the velocity is constant, what is changing is the direction. This can be written as p squared over r. And this is the definition of centripetal acceleration. It's only applied if the object is moving in a circular path. There is another exercise on how to prove this equation. So now you have the gravitational pull. You have another way to write ma. Ma can be written as mv squared over r. So you just do, let's call this G for gravitational pull and C for centripetal. But remember, this is just mass times acceleration that can be written like this. And this is Newton's universal law. So as you can see, one mass cancel, one r cancel, and this now we take a square root on both sides. The mass cancel here. And the velocity is g over r. And remember that a square root can be written as exponent 1/2. And this is how it's in your textbook.